Hi everyone, welcome to Learning Math with VK. Today we explore lesson 24 in algebra, radical function and application. Number 1, radical function. Let's take a look at fx equal to square root x. We call this the parent square root function. Let's plot the points here and see what it looks like. X, y equal fx. The point x, y, x0, right? Root of 0 is equal to 0. 0, 0. 1, root 1 is equal to 1. 1, 1. Next number is 4, because root 4 equal 2. 4, 2, 9. Root 9 equal 3. 9, 3, and so on. X, Y. 0, 0. 1, 1. 2, 3, 4. 4 and 2. 5, 6, 7, 8, 9. 3. Connect the point and we have this. This is the shape of the square root function. From here, we can see that the domain is from 0 to infinity, including 0. And then the range here is from 0 to infinity, including 0. The parent function is very useful because we can use it to sketch pretty much any square root function. Example, sketch. Gx equal to root of 4x minus 8 plus 1. To do this, first we can simplify by factor out 4. So this root of 4 x minus 2 plus 1, which gives us the root 4 is 2. So 2 root x minus 2 plus 1. And then we're going to use translation. Number 2 tells us to vertical stretch. That means slope is getting steeper. Minus 2 tells us to shift right 2 units. Plus 1 shift up 1 unit. Let's take a look at the graph. X, Y. First, I'm going to sketch out the parent function. So this fx equal root x. And then we're going to slowly sketch the graph of gx using, of course, translation. Do a vertical stretch. Shift to the right 2 units. 1, 2. We're going to shift up by 1 unit. 1. final graph is this one. It is gx. The domain here is going from 2 to infinity. The range here is from 1 to infinity. Application. A tennis player hit a ball at a height of 2 meters. The ball flies and hit the ground after 0.25 seconds, a distance of 20 meters from the tennis player. How fast is the tennis ball traveling? Let's sketch out. So initially, we have the ball here. And the tennis hit it. And it flies. This the ball. Hit the ground later. This is the right triangle. It's 2 meters, and this distance is 20 meters. The distance is d. To figure out how fast the ball travels, we got to figure out the distance, and then we can use physics to figure out distance is called speed times time, so we can figure out the speed. How fast? We just got to figure out the speed here. To find d, we use the Pythagorean Theorem. Which state that, well, for any right triangle, which side A, B, C, then A square plus B square will always equal to C square. You can prove this easily just by constructing a model. A square is the area, B square is another area, and C square is another area. Just make sure that the area are the same. Using that, you can use water. That's the fastest way to prove this. Now, how do we use it? Well, we have a 2 square plus 20 square, and that would equal to exactly d square, meaning that d is going to be a square root of 2 square plus 20 square, or square root of 404. Okay, next step is move on to the speed. From physics, to find speed, use distance equals speed times time. We know distance is root of 404. Speed, we don't know, so I'm going to call it x. But then we know time, 0.25. So I mean the speed x is root of 404 divided by 0.25, and that gives us x to be 0.399 meter per second. And that's fast. Example, a ship's radar system indicates an unidentified object. The object is located at coordinate 45 and the ship is located at coordinate 12. How far is the unidentified object from the ship? Assuming one unit is 10 nautical miles. We can do this problem by just sketching out and plotting the points. However, I want to introduce you to a new formula, and we're just going to use that formula. And that is the formula to compute the distance between 2 points, x, y. Let's say that the first point is x1, y1, coordinate x1, y sub 1. Second point, x2, y2, coordinate x2, coordinate y2. This is the distance between them, and this is the distance d. We can get a right triangle that include d. The vertical side is y2 minus y1. The horizontal side is x2 minus x1. And ta-da! Using Pythagorean Theorem. D square is y2 minus y1 square plus x2 minus x1 square. So D is going to be the square root of y2 minus y1 square plus x2 minus x1 square. Now we can just use substitution to figure out D. And that would be square root of, second point is y2, first point is y1. So y2 is going to be a 2 minus 5, and similarly, do the substitution for x2 is going to be 1. x1 is going to be 4. And ta-da! We have root of 9 plus 9. So that is root 18, and root of 18 is 4.24 unit. To convert it into nautical miles, we just multiply by 10 miles. And that gives us 42.4 nautical miles. Yep, babe. That is the distance between the ship and the unidentified object. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.